All right, well, let me go ahead and shut the door, and then we will get started. Okay, so the big item is, of course, on Monday, you're taking your exam. And I went ahead and posted next week's website information. So if you were to go ahead and take a look at that, again, I've got a whole listing, not only on this current week, but next week's, exactly what you want to go ahead and look over in order to prepare for the exam. Now, I did mention this yesterday. I'll go ahead and mention it again. If you look at this current week, the 21st to the 25th, under trig functions on the unit circle, this is the lesson that I'm teaching from. You have the blank notes, you got the full notes, and then at the end, you have the homework assignment. Okay, this is going to be due on Friday, but you only have to work the circled problems. And I'm really encouraging people to practice this. And that's the key word, practice. That's the only way we're going to get better. I did also go ahead and post right by it the answer key. So if you're not able to make it in for tutorials, you can at least check your progress and see how you're doing. All right. As far as the rest of everything, remember next week I'm not going to have any morning tutorials because I have morning duty in the dining hall. So tutorials next week, not this week, will be from 3:55 to 4:20. If anybody needs to come in and ask me any questions. This coming Friday, we do have a CFA quiz over our current lesson. What's the CFA quiz? That means you take it how? Yeah, you're using the Chromebook. It's online. Okay, so it'll be multiple choice. So hopefully that won't be too bad. The unit circle projects are due on Friday. I do have copies of the rubric over there if anybody needs one. I'm going to record it as a test grade. Just let me know if you have any questions. Happy Minutes will start tomorrow. We're going to start off real basic. Just the 6 trig functions in terms of opposite, adjacent, and hypotenuse. Should be a guaranteed good grade. I believe that's all I have. You are allowed to use a 3x5 index card during the exam. So anything you wish to write on that index card, that's going to be perfectly fine. Okay, well, let's go ahead and get going. Hello. Okay, so we were talking yesterday about evaluating trig functions on the unit circle. We were talking about quadrantals, and we finished up with reference angles, which are going to be key. Now, I'm going to go ahead and show you this 2 different ways. I'm going to show you how to evaluate with a unit circle in front of you, but then I'm going to go ahead and show you how to evaluate one without the unit circle, which is the preferred method I'm going to want you to use. Okay, because we won't always have one of these in front of us. Now, one of the ideas we talked about yesterday, remember each of these points here, even the points that we haven't identified yet, they can all be written in terms of cosine, comma, sine. Okay, so it's crucial. Cosine is your x value. Sine is your y value, just like we talked about yesterday. Well, we're going to take 2 parts to do this. First, we need to figure out, given the angle measure, whether it's degrees or radians, it does not matter, where the terminal side is. Well, wherever he stops rotating, you're going to have an ordered pair there. The trig function is then going to tell you what to do with the ordered pair. So let's try an example. Let's say I want sine of negative 120 degrees. Well, what's the negative tell me to do? How am I going to rotate with a negative angle? I'm going to rotate clockwise, right? So from standard position, I'm going to go ahead and rotate. What quadrant would this put me in? It put me in quadrant 3. So if I started here and rotated, this is negative 120 degrees. So this is going to be right here. So you'll notice negative 120 is coterminal with 240. All right, means they have different angle measures, but the same terminal position. Well, wherever we stop rotating, see we have this ordered pair. Now I'm going to look at the trig function. Remember, sine is the y value. So what's the y value at this location? Negative square root of 3 over 2. There you go. What if I said, okay, I want cosine of negative 120? Negative 1/2. That would be the x value at that location. What if I said, okay, I want sine of 240 degrees? See, it's still negative square root of 3 over 2. Okay. Doesn't matter what the angle measure is. If it's the same location, you're going to be dealing with the same point. Okay, well, let's try another one. Let's say cosine of 2 pi over 3. Well, what quadrant is 2 pi over 3 in? It's in the, what, Philip? Second quadrant. So if I started here, it's positive, so I'm going to rotate counterclockwise. Well, here is 2 pi over 3, so that's my terminal side. All right. Well, the ordered pair I have at that location is negative 1/2 square root of 3 over 2. I want cosine of that angle. Well, we just said a second ago, sine is the y value. What's cosine? Cosine is the x value. Well, what's the x value of that coordinate? Negative 1/2. There you go. Okay. First, you determine what ordered pair we're going to be looking at based on the terminal side, bless you, the angle, and then you use the trig function to figure out what you want there. Okay, let's try another one. Tangent of 300 degrees. Kaushal, what quadrant's that in? Fourth quadrant. Okay, so I'm going to start here. It's positive, so I'm going to rotate all the way around. Here is, bless you, 300 degrees. Okay, there you go. So there's 300 degrees. So here is the ordered pair that corresponds to that particular angle measure. But now here's the thing. I don't want cosine or sine. I want tangent. When we looked yesterday, tangent is the y value divided by the x value. Remember, with this lesson, we're getting a push away from the opposite, adjacent, and hypotenuse. We want to label the sides in terms of x, y, and r, the radius. Well, all this tells me to do, because tangent wants y over x, I want to take this y value and divide it by that x value. So tangent of 300 would be the result. Okay, so let's see here. I'm going to take the y value, negative square root of 3 over 2, divided by 1/2. What happens when you divide by a fraction? Hey, you're going to multiply by the reciprocal. So this is negative square root of 3 over 2 times 2 over 1. Well, those 2's are going to cancel, so it looks like tangent of 300 degrees would just be negative square root of 3. Okay. See, I did to that ordered pair what tangent told me to do. If I'd had cotangent of 300, then I would have taken the x value and divided it by the y value. Okay. Now, again, I just want to bring up another point. What if I said, okay, I want tangent of 5 pi over 3? Do you notice anything? What's 5 pi over 3? That is 300 degrees, right? And here's the point. It doesn't matter if you're provided radians. It doesn't matter if you're provided degrees. The answer is still the same. Because whether it's radians or degrees, that tells you where to stop and what ordered pair to use. How's everybody doing? Okay. Let's try this last one. I want secant of negative 5 pi over 4. Okay, secant of negative 5 pi over 4. Let me give you about a minute. Okay, look on the unit circle and see what we need. Now remember, secant, according to what we started looking at yesterday, wants the radius divided by x. Remember, he's the reciprocal of cosine. Okay. Now, in this case, since we're on the unit circle, what does the radius equal? 1. It is 1. Okay, very good. Okay, so the key question is, what quadrant would negative 5 pi over 4 fall into? Okay, Kate says 2. In fact, what would it be coterminal with? Yeah, 135 degrees or 3 pi over 4. For the people who aren't here, a good way to think about this, look at 5 pi over 4 just positive. So if I started here, I'd have to rotate half a revolution and then go half of a quadrant. There's 5 pi over 4. Well, we just want to go the same direction, or excuse me, the same distance in the opposite direction. So I'm talking about this point right here. That would be negative 5 pi over 4. Now, I want to take the secant of that location. So his ratio is r over x. Well, we just said the ratio r is 1 over. Well, what's the x value at that location? Negative square root of 2 over 2. So I'm going to say negative square root of 2 over 2. And see, now all I have to do is a little bit of algebra, and I'll know what secant of negative 5 pi over 4 is. Okay, so I'm going to multiply by the reciprocal. So this would be negative 2 over the square root of 2. We'd be multiplying it by 1, but that doesn't matter. So now I do have to what? Rationalize. So square root of 2 over square root of 2. This would give me negative 2 square root of 2 over 2. And you'll notice when those cancel, we should just be ending up with a negative square root of 2. Okay. Did anybody happen to have that correct? Nice. Nice, nice, nice. Okay. Easy, right? If you got a unit circle in front of you, there's no problems. Now remember, about half the questions on the exam will be like this. Okay, so if you go ahead and put a unit circle on your index card, could make it a little easier. Okay, now that's not the way I would prefer you to do it, but you do have that option. Okay, in fact, let's go ahead and look at some of these now where we won't have the unit circle in front of us. Okay. Now, we still have to go ahead and determine what quadrant the angle measure is going to place me in. Now, the key here is to draw a right triangle based on the reference angle. Okay. So let's just get right into a problem and see what we're going to do. Find the exact value of sine of 4 pi over 3. Okay. So, Josh, what quadrant would that put me in? 4 pi over 3. 1, 2, 3, or 4? Ooh. Oh, you're right. I'm sorry. I don't know what I'm thinking about. That would be 3. Okay. So I'm going to go ahead and draw this right here. Let's say like this. So this is 4 pi over 3 radians, right? Now, we don't have a unit circle in front of me. So knowing where the terminal side is, I'm going to connect him to the x-axis and create a right triangle. It's always connected to the x-axis. Now, what I said a moment ago, this triangle is going to be created based on this reference angle. Okay. Well, think about it. If I rotated 4 pi over 3 radians and I passed pi, well, what would that reference angle be? Okay. The reference angle is pi over 3, right? All I would do is take the 4 pi over 3 that I rotated and subtract the pi, the measure of the x-axis. Okay. So it's going to give me pi over 3, but let's go ahead and create the triangle in degrees. What is pi over 3 in degrees? 60. So this would be 60 degrees. This would be 30. And here's the thing. Because I'm going to be having you evaluate these trig functions without a unit circle, you have to get one of these special right triangles. The reference angle will always be 30, 45, or 60. It has to be one of those 3. Now, eventually, we're going to move beyond that, but that's all our universe is working on right now, just the unit circle. So let's kind of revisit these for a second. Okay, so these 2 triangles represent our special right triangles. So we have the 45, 45, 90. We've got the 30, 60, 90. Okay. Now, the hypotenuse of these triangles is the radius of the circle. So we know that's 1 because we're dealing with the unit circle. But does anybody remember, given a radius of 1, what are the identical leg lengths for the 45, 45, 90? Square root of, what is it? Square root of 2 divided by 2. Okay. This is one of those 2 triangles that continually showed up on the unit circle when we first talked about it. Remember, it has the relationship that the legs are just x. The hypotenuse is a leg times the square root of 2. All right. Now, with the same radius in a 30, 60, 90, well, what's the side length across from 30? 1/2. What's across from 60? Square root of 3 over 2. So 1/2 times the square root of 3. It has the relationship, the shortest side is x, the longer side is x times the square root of 3, and then the hypotenuse is double x. Okay. So if we know we're only going to be ending up with one of these 2 triangles, well, we're just going to be using the same side lengths over and over again. We're just applying it to this one. So we ended up with a 30, 60, 90. We know that 1/2 is across from 30. Square root of 3 over 2 is across from 60 with a radius of 1. But I can't help but feel that I'm forgetting something. Okay, Kate, what's that? Negative. Good. What quadrant are we in? In the 3rd quadrant, both x and y are negative. Okay, because really what you're doing, these legs would give you this point on the unit circle. It would be negative 1/2 negative square root of 3 over 2. Okay, now remember, we want sine of 4 pi over 3. Okay, well, here's the x value, here's the y value, and here's the radius. So what would sine of 4 pi over 3 be? Yeah, what's the y value at that location? It's got to be negative square root of 3 over 2. There you go. So that's what we're going to have to do if we don't have a unit circle in front of us. Okay, we're going to use the angle to determine which quadrant it's in, then create a right triangle using the reference angle. And it has to be 30, 45, or 60. It's got to be one of those two right there. And then you just evaluate the trig function based on that reference angle. In fact, let's take a look. Sine of 4 pi over 3, if I do come back over here to the unit circle, here's 4 pi over 3, and the y value is negative square root of 3 over 2. All right, let's try another one. The next one I believe is tangent of 150. Okay, so let me get this out of the way. So tangent of 150. Okay, Kasha, what quadrant would 150 fall into? Second. So I'm going to go ahead and do this right here. Let's say that is 150 degrees. So I'm going to use this terminal side right here to create a right triangle, always with the x-axis no matter what quadrant I fall into. Well, what's this reference angle right here? Yeah, it's 30. So this is 30. Okay, that means this one's 60. So again, it's that 30, 60, 90 triangle that we were just looking at. We know the radius is 1. What's across from 30? Across from 30 is always 1/2. Across from 60 is the square root of 3 over 2. Now, what's negative in the second quadrant? Only x. So I'm going to place a negative on the x value. And there we go. So now here's the thing. If I said, okay, I want sine of 150 degrees. Well, remember, sine is the y value. So you would say 1/2. Let's say I want cosine of 150 degrees. Okay, well, what's the x value? Negative square root of 3 over 2. See, if it's cosine or sine, you just have to label the x or the y value. But this one wants what? Tangent of 150. And tangent wants the y value divided by the x value. So once I have my triangle, I'm just going to do what the trig function tells me to. The y value is 1/2, and the x value is negative square root of 3 over 2. Okay, and now just a little bit of algebra, and you'll have exactly what you need. What do I do again if I divide by a fraction? I keep forgetting. Multiply by the reciprocal. So this is 1/2 times negative 2 over the square root of 3. So those 2's are going to cancel. So it looks like I've got negative 1 over the square root of 3. Can anybody tell me the final answer without my having to write out the rationalizer? Negative square root of 3 over 3. There we go. And this is something that you can check in your calculator, because on the test, I'm not going to allow decimal values. You got to give me the fractional. But let's test it. I'm going to come on over here. That's tangent of 300. Let me document B out of here. So tangent, okay, of 150 degrees gives me negative 0.57735. But our answer, we said, was negative square root of 3 over 3. There you go. So maybe that's another way to kind of help you confirm that you are getting the right answer. Okay. All right. Are we ready for one on our own? Okay, now try this one. Secant of 15 pi over 4. Yes, sir. I believe I actually have a few extra. I don't know that I have enough for everybody, but I do have, yep, there you go. Now, the first thing you'll notice, 15 pi over 4, if you were to go back and look at your unit circle, I don't see a 15 pi over 4 on there. Okay, so that means wherever he stops, it has to be coterminal with one of these 16 points. So right now, I will not be giving you an angle that does not appear on the unit circle, but it could be coterminal. All right? So let me give you a couple minutes to take a look at that. And maybe you won't even need a couple minutes, but there you go. And maybe some of you don't even need to do this. Do you guys know how to find the trig functions on your left hand? Have you ever been shown how to do that? Maybe at some point I'll show you guys how to do it. But it's really easy, and it's actually pretty accurate. Okay, so we're going to try this no unit circle. Okay, find what quadrant 15 pi over 4 would be in. Use that to create a right triangle. The reference angle will create a special right triangle. Then, given the side lengths, find secant. Okay, so any of you folks get the answer. What do you think it is? 3 square roots of 2 over 2? A little off. Okay. Anybody else? Okay, well, let's start at the beginning. Where would 15 pi over 4 place me? In what quadrant? That's an important factor. It would be the fourth, okay? So while we don't recognize 15 pi over 4, we know it's got to be coterminal with one of those 16 values we've been looking at. So 15 pi over 4 is 3 3/4 pi. Remember, one of these strategies I've used is to rewrite it as a mixed number. So if this is 0, then we have pi over 2, we have pi, 3 pi over 2, and then 2 pi. All right, so this right here, that's 1 pi, 2 pi, 3 pi. Okay, so that takes care of that. But now I just need to rotate 3/4 pi, but remember that's 3/4 of half a rotation. So it's going to place me in the fourth quadrant. Okay, so probably something that looks like this. Okay, that's where 15 pi over 4 is going to place me. Well, I'm going to go ahead and connect that to the x-axis just like we've been doing. Okay, create a right triangle. Now this right here is key. What's the reference angle? It is 45 degrees. Remember, after we did 3 pi, we only had to rotate an additional 3/4 pi. So in order to make half a revolution, it would be pi over 4. That's my reference angle, and that is 45 degrees. Okay, so I'm going to go ahead and say 45 degrees. This is 45 degrees. Well, we know we're dealing with the unit circle, so the radius is 1. What were the identical leg lengths for this triangle? The x was square root of 2 over 2, y square root of 2 over 2. But again, am I forgetting something? Which one, though? There you go. In the fourth quadrant, y is negative. There we go. So I used 15 pi over 4 to find the quadrant I'm in. I created a right triangle based on the reference angle that I got. So now I want secant of this triangle that I created. If this thing would erase, let's try this one more time. There we go. Remember, secant wants r over x. Secant's the reciprocal of cosine. But what's the radius in this case? Remember, it's 1 because we're on the unit circle. So this would be 1 over, well, the x value is the square root of 2 over 2. So now we just need to multiply by the reciprocal, so 2 over the square root of 2. If I were to rationalize, all I'm going to end up with is the square root of 2. Okay. Now, is your calculator in radians? That's the thing. Now, if you go ahead and plug it in with degrees, what's equivalent to that, it should work out nicely. That's the thing. So let's try this. 15 pi over 4. I mean, what would that be? 315 degrees? That'd be coterminal with it? Now, I'm not saying that's equal to 315 degrees. I'm just saying it's coterminal with 315 degrees because of the position and the reference angle that we got. Okay? So if I were to come on over here, let's go secant. Secant of 315. So I got 1.41421, but we said our answer was the square root of 2, which is that. And that's the thing. You don't want to forget what mode your calculator's in, because that could make you think you've made a mistake. Okay. So you did get the right answer, or you just got confused by the calculator? Okay. Good, 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 good. Okay. Well, good, good. Well, let's try another one of these. Now, we've already done 4 pi over 3. Why don't I go ahead and let's do something we haven't seen since yesterday. How about 7 pi over 2? Okay, change it to something different. So cosine of 7 pi over 2. So you guys walk me through this one. First, where would 7 pi over 2 put me? There you go. See, this isn't in a quadrant. It's going to end up on the y-axis, the positive y-axis. So this would be 3 and 1/2 pi. So if I were to rotate, there's 1, there's 2, there's 3, and then we go 1/2. So it is on the y-axis. Okay. Now, if it's a quadrantal, you're not going to be able to create a triangle here because one of your side lengths would have to be 0. But you're still just going to use the point that's available. Okay. Basically, this is equivalent to, or I should say coterminal with 270 degrees, -90. But the ordered pair there is 0, -1, right? So what would the cosine of 7 pi over 2 be? It would be 0. So if it stops on an axis, if it's a quadrantal, you will not be able to create a triangle. Only if it's in a quadrant. Okay, what do we think? Doing all right? Okay. All right, well, let's go ahead and switch things up a little bit. Let's look at this next problem. Now, I did put a problem like this on the exam. So again, another style of problem that we want to be familiar with. It says, let secant of theta equal the square root of 29 over 5, where sine of theta is greater than 0. Find the exact values of the remaining 5 trig functions of theta. So all I want to do is just list those fractional ratios. What does sine of theta equal? What does cosine of theta equal? I'm not interested in theta itself. I don't want to know what theta is. I don't need to. Now, in order to work this problem, first we have to figure out what quadrant my triangle is going to be in. Okay, and they are providing me little clues here. Did I mention anything yesterday about how to tell where a trig function was positive? What was that sentence? All students take calculus. So all students take calculus. So in the first quadrant, all 6 of the trig functions were positive. What about the second quadrant? What was that S for? Sine and cosecant. What about the T? Tangent and cotangent. And the C, cosine and secant. Okay. So these are the quadrants where these trig functions will be positive. So this is also useful if you know where they're positive. You're also going to know where they're negative. Now, here's how I like to do this. This is how I did this, way back in the day when I was shown this. The first thing I see is that sine of theta is greater than 0. Well, what I'm being told is that sine is positive. So I'm going to go ahead and place a little check mark in every quadrant that satisfies that statement. So what two quadrants is sine positive? It's in the first one and the second one. Okay, so that takes care of that. So now I'm going to switch my attention to secant. Am I given a positive or a negative secant ratio? It's positive because square root of 29 over 5. So what two quadrants is secant positive? Okay, 1 and 4. So I place a check mark in those. What quadrant do you think this triangle has to fall into? 1, because it has the most check mark. It's the overlap that's going to satisfy these conditions. Okay. So even though I don't know what theta is, okay, I know my terminal side is going to lie there. Okay, I would rotate that far. Well, just like before, I'm going to create a right triangle, always with the x-axis, based off that terminal side. Okay. Now, in order to find those functions, the ratios, I got to know what the sides of the triangle are. Are they giving me any of those? Which two? There you go. Remember, secant's ratio is r over x, right? So square root of 29 over 5 should equal r over x. So I see that the radius should be the square root of 29, and I see that the x value should be 5. Well, great, that found me two sides, but now how do I find the third? Pythagorean theorem. So we're looking for the vertical, so we're looking for y in this case. So let's see, y squared plus 5 squared is equal to the square root of 29 squared. Okay, let me go ahead and give myself a little more room here. Well, that's y squared plus 25 is equal to, what happens if you square a square root? Okay, 29, you just lose the radical. So y squared is equal to 4 when I subtract. So what's y? 2. And there we go. Okay. So this now kind of just goes all the way back to when we first started the unit. I've got a triangle that I know all three sides for. Now I just want the 6 trig ratios. So for example, sine of theta is equal to y over r, right? Well, we found the y value to be 2. The radius was given to me as the square root of 29. And I just have to rationalize. In fact, Kaushal, what would be that final answer? There you go. Now let's say I want the reciprocal cosecant. We know that's the radius over y. Okay. Well, the radius again was the square root of 29 over y 2. That one's really nice to me. I don't have to simplify and I don't have to rationalize. So that one I got the answer. Is everybody okay with what I've done here? Any questions? Okay, well, let's find cosine. Cosine's ratio was x over r. So this is 5 over the square root of 29. In fact, remember, that's just the reciprocal of what I had in the beginning of the problem. Okay. So what would that be? Joshua, can you help me out with that? After I rationalize, what would be the final answer for cosine? Yes. So both parts I'm going to multiply by that square root of 29. So what would that give me? Okay. So you're okay with that version of 1, right? Okay. So now just multiply straight across. What would 5 times the square root of 29 give me? Oh, now remember, we're not going decimal. We're just going to leave it as a radical. That's exactly right. 5 square root of 29 over 29, because the radicals would cancel. And 5 and 29 will not reduce, so that's got to be my cosine. Now, we already have secant. We don't have to worry about that. What's left? Cotangent and tangent? Tangent of theta is now y over x. So what would that be? 2 over 5, 2/5. So cotangent, I'll just go ahead and write it out. It's now x over y, but the reciprocal of 2/5 would just be 5/2. There you go. Okay. So the major part of this problem, there's nothing new. It's just getting the correct diagram in the right quadrant. Okay. So let's try another one of those. It looks like this will be our last problem today. Let cosecant of theta equal -3, and let tangent of theta be less than 0. Okay, so the first thing we got to figure out is what quadrant. That's key. Okay, so let's start there. Look at your clues. Remember, it's all students take calculus. Because tangent is less than 0, I know tangent is negative. Cosecant is -3, so that's a negative as well. Okay, so I'm looking for that one quadrant where tangent and cosecant can be negative. You okay? Excuse me. Okay. Can anybody tell me what quadrant should this belong in? Okay, so Philip says second. Do you guys agree? Okay. I'm kind of thinking another quadrant, though. Looks like what two quadrants would tangent be negative? Okay, so the second and the fourth, right? So I'm going to put a check mark there, check mark there. Okay. Now, cosecant. This is the reciprocal of sine. What two quadrants would cosecant be negative? What's that, Kasha? 3 and 4. Okay. So according to my signs, this has got to be in what quadrant? It's got to be in the fourth quadrant because that's where I have the most marks. This is the one quadrant that satisfies these two conditions right here. So there's my terminal side. Let me get rid of the C. All right. I'm going to go ahead and use the x-axis to create a right triangle. Theta becomes my reference angle. It's always about the reference angle. Okay. Now, it only gives me -3. How is that going to give me two side lengths like the previous problem? There you go. If you're not provided a fraction like -3, well, you can just make it a fraction just by putting it over 1. Now remember, what is cosecant's ratio? He wants what over what? The radius over the y value, right? So I know here the radius has to be 3. The y value has to be 1. The only question is, which one has to have the negative? The 1. The radius will never, never be negative. It's always positive. And there we go. So now that I have two sides of the triangle, how do I find the third? Pythagorean theorem. Okay, so I'm looking for x. So this would be x squared plus a -1 squared is equal to 3 squared. X squared plus 1 is equal to 9. So x squared is equal to 8. So as soon as I take the square root, now again, this is one of those where it's not a perfect square, but I do want to reduce it. Again, no decimals. So what would x equal? 2 square roots of 2. There you go. Now all we got to do is just find those 5 other ratios. Okay. Let's start with sine. Sine of theta. Well, remember that's y over r. Well, y is -1 over r3, so -1/3. And that makes sense because sine and cosecant are reciprocals, and -1/3 is the reciprocal of -3. Okay, let's look at cosine. Cosine is x over r. So Joshua, can you help me out with that one? Oh, not just -3. I want the x length divided by the radius length. So what was the horizontal x value we found? 2 square roots of 2. And what were we given the radius to be? 3. And do I have to simplify or rationalize or anything? No, that one's good to go. Okay. Now let's find secant, which is r over x. Okay. So I'm going to take the radius, 3, over the x we found from the Pythagorean theorem, 2 square roots of 2. Now this one I am going to have to rationalize. Square root of 2, square root of 2. Anybody tell me what my final should be? Okay. Ooh, negative? Remember, in the fourth quadrant, secant's going to be positive. I'm getting 3 square root of 2 over 4. There we go. And then all we'd have to do is find tangent and cotangent. But it looks like our time is almost up. All right. How are we doing? Now, again, we're going to practice this again tomorrow, so don't worry. Okay. Mr. Yacht will be here, and he will go ahead and work some problems with you. Oh, here we go.
Teachers, in just a few moments, we'll be releasing questions.